Okay, so let's continue our development for the formula of the surface area of a solid of revolution. So let's just review what we did earlier. We decided to approximate the curve, which is what creates the surface area of this solid of revolution when we revolve it about the x-axis, using the secants joining the endpoints of the subinterval. So this creates this approximation for the surface area, and by extending these two lines we realize that that shape was just the bottom part of a cone. So our goal now is to find a formula for this bottom part of the cone, which as I said is called the frustum. So let's do that now. So here we have a model, and what we're looking for is the area of this bottom portion. So we're going to do that by subtracting the area of the larger cone by the area of the smaller cone. So just a reminder that the lateral surface area of a cone is given by pi times the radius times the slant height here. So we'll call the slant height of this smaller cone L1, and for the slant height of the larger cone I'm not going to call that L2, because in the end what I want to be working with is this measure here, which would represent the length of the secant joining the endpoints from the previous diagram. So I'm actually going to call that one L, and so the slant height will just be L1 plus L. I need the radii, so we'll call this one R1, we'll call this one R2. So let's now find the area of that surface area. So there we go, or the area of the frustum. So we're going to take the area of the larger one, so that's pi times R2 times the slant height, which is L1 plus L. Okay, and then from there we're going to subtract the surface area of the smaller one, which is going to be pi times R1 times L1. Now eventually what I'd like to do is only work with L and not have L1 at all. So let's see what we can do with that. So we'll rearrange. So pi R2 L1 plus pi R2 L minus pi R1 L1. So I'll bring together everything that's got an L1. So pi R2 minus R1 times L1 plus pi times R2 L. So our goal here is to somehow get rid of this L1, and we're going to use the fact that we've got similar triangles here in that diagram. So let's work with that. So we'll create a proportion. Say L1 over R1 is going to be equal to L1 plus L over R2. Alright, let's do a bit of algebra and see where that takes us. So we've got R2 L1 equals R1 L1 plus R1 L. Okay. So now let's again take everything in terms of L1. So we've got R2 minus R1 times L1 by bringing that to the other side equals R1L. And we notice that this expression here is exactly the expression that we have in our area formula. So let's insert that in there. So now the area can be written as R1L. Oh, let's remember we've got the pi there. So pi times R1L plus pi times R2L. And simplify that a little, and we've got pi R1 plus R2 times L. Now let's think about what R1 and R2 would represent. So we'll bring back the other diagram here, okay, and we realize that R1 and R2 would just be the function values at the endpoints. Now we don't want the function values at the endpoints. Remember, we'd like at some point the function values at some random CI. And if you think back to what we did with the trapezoidal approximation, when using both function values at the endpoints, we weren't able to create a Riemann sum. So still have a bit of work to do. So the first thing we're going to do is we're going to do one of those little clever mathy tricks that I guess some smart person came up with, and we're going to actually multiply this by 2 over 2. And if you take this whole expression here, we realize that that just represents the average of the two radii. So I'm going to rewrite that as pi times, sorry, screen just went dead for a second, times R1 plus R2 over 2 times L times 2. And we're going to bring that 2 to the front. And we're actually going to replace this whole expression by R. Okay? So essentially what we have is that the area of the frustum is given by this formula where R is equal to R1 plus R2 over 2. Now, we haven't quite gotten rid of R1 and R2, but maybe you're already seeing where this is going to be going. So we'll finish this off and create our Riemann sum in the third video.